Good evening, everyone. Welcome to the sixth video solutions. Today I'm a bit late because I had some other work. So as a result of it, I was not able to arrive in time. Anyway, without wasting time, I will just complete this. Oh, now it's already 6:05. Okay, so let me finish it up as soon as possible and then upload it to YouTube. Just a moment. Okay. So this is my sixth video, I think, solutions for sixth video. Yeah. Sixth video. Okay, I hope it is getting useful for so many people, and I have seen some of you attempting it, some of you not getting the answers, some of you getting the answers, and saying that, okay, these portions were not completed and so on. Anyway, let us continue. Okay. So a block of mass 1 kg rests on a trolley of mass 4 kg. So let me write it down. This is my 1 kg mass. This is my 4 kg mass. The coefficient of dynamic friction between the block and the trolley is 0.3. So here it is 0.3. None of them got the answer here, I feel. The horizontal force of F equal to 5 Newton acts on the block. So there's a force 5 Newton acts on the block. The slides over the trolley. Okay, this block now starts moving. Now, what is the acceleration of trolley? What happens to a trolley? Will the trolley also moves? Now, this is a wonderful question, wonderful to me anyway. So what happens is, first thing is, when you say the coefficient of friction is given, in such cases wherein you have objects that are being stacked one above the other, first find out what is the frictional force acting here. There's a frictional force that acts between these, right? Find out what is the frictional force here. This frictional force is nothing but 0.3 multiplied by 1 multiplied by 10, which is equal to how much? Which is 3 Newton. So 3 Newton forces is the frictional force, which means if you apply a force of 3 Newton here, okay, the object will not move. Do you agree? Because there's a static friction here. Okay, you have the object, you apply a force of 3 Newton. Until the force is 3 Newton, there's always an opposite force of 3 Newton acting here, friction being a self-adjusting force, and as a result of it, the object should not move. Then, since you have applied an extra force of 2 Newton, because the total force applied is 5 Newton, so you applied a force of 2 Newton more, so what do you expect? That this object 1 kg will now start sliding like this. It will automatically start sliding like this and move away. Okay. Now, the question here is, it's not about what is the acceleration of this object. The question here is, what is the acceleration of the trolley? Read the question once again. Acceleration of trolley. Now, why should the trolley get accelerated? The reason is, see, why I am asking this question is, there is a force that is acting on this object, not on this object. Okay. Since this force is much larger, it will automatically go away. Okay. The upper object will go away. But why should this get accelerated? Now, towards it, you have to apply Newton's third law. What is Newton's third law of motion? Action and reaction are equal and opposite. Now, you see, where is this 0.3 Newton acting? Sorry, 3 Newton acting here. This 3 Newton is acting on the upper block. Who pushes this? So, this fellow, the lower block, because of friction, it tries to avoid this object to move away. So, 3 Newton has been acted like this. So, this is my action force. Now, because there's an action force, what should the object do? The object should also give a reaction force. Now, what should be the reaction force? Reaction force should be on this object, and because action, if it acts on one object, reaction should act on the other object. So, reaction is acting here, and what is the force equal to? This should be equal to 3 Newton once again. Okay, so remember, action is acting here, reaction is acting here. Reaction is acting here. So as a result of this, now this object will start moving, right? So hence, now what will happen? The total force acting on this object is 3 Newton. 3 Newton divided by, what is the total weight over here? What's the total weight over here? That is this should be 5 over here. 5 kg. Just a moment. I'm just stopping this. Just give me a moment. Somebody at the door. I'm just coming. Okay. I'm back. So where was I? Okay, I'm sorry. This is 3 Newton. Where did I put 5? Oh my God. 3. What happened to this here? Okay. This is 4 kg. Why 4 kg? Because I am talking only about the acceleration of this trolley. Okay, they are not moving together. This is moving faster. This is moving slower here. Okay, so this net force divided by net mass. Okay, the force acting on this object divided by the mass of this object. This will give me my acceleration, which should be equal to a 0.75 meter per second square. Okay, so this is the acceleration of only this object. Okay, so it is not the acceleration of this and this together. It's only the acceleration of this object. Thus, this trolley is now moving at 0.75. I hope you understand this. Where is my cursor here? Okay, it's here. I hope you understand this problem. This problem is, it's not tough. I can say you need to have a good insight on it. There are several concepts that have been stringed over here. The first concept is finding out the static friction and thereby understanding that why should this object slide. Okay, and second question is, okay, if this object is sliding, then there is an action force. Which one is the action force? Friction now acts like an action force. Reaction is given over here. Okay, so because of this reaction force, now you consider that this object alone now slides, which means now this is moving with a given acceleration. If I ask you what is the acceleration of this one, this would just be 2 divided by 1, right? Because the net force is 2 here, not 5. Okay, 5 is applied here, 3 is taken away by friction, so 2 is the net force. 2 divided by 1 will be equal to 2 meter per second square. Okay, but while the trolley is moving with an acceleration equal to 0.75 meter per second square, which means what? If you continuously keep on applying the force, then after some time this object will fall away, right? As compared to this. That's what it means. So thus the right answer is 0.7 meter 5 meter per second square. There are 3 concepts which have been included. If you do not understand, do look at the video once again to understand it, to get a clarity of this. Okay. Well, let us move on to the next one. A tennis ball is released from rest. Very simple problem. Tennis ball is released from rest at a height h. At a height h. After each bounce, 50% of its kinetic energy is lost. The moment this, when say it is at a height h, we know that the potential energy at this point is equal to mgh. Now, when the ball keeps on coming down, now it will gain its kinetic energy and loses its potential energy. So therefore, at this point, when it touches the floor, the kinetic energy is half mv squared. Now, what does it say? At each bounce, 50% of the kinetic energy is lost. Okay, 50% of it is gone. So as a result of it, when it bounces back, so what will happen? This will not have half mv square, but this will just have half of half mv square. Now, to what height will it bounce? It will now bounce to half of mgh, because half mv square is mgh, right? So it will now bounce back to only half of mgh, which means what height will it go? I can now write this as mg into h by 2, right? I bring this 2 inside, which means it will now just go only to a height of h by 2. So after the first bounce, what is by us? After its second bounce. Okay. So after the first bounce, it goes only to this height, which is h by 2. Now once again, now what is the potential energy here? Potential energy now for this object. Initially it was here, now it has come to here. Just give me a moment, somebody is calling me. Okay, I'm back. Oh, where is my video? Okay, fine. Right. Sorry, yeah. Okay, somebody was in call. One student did not attend, so I had to start with it. Okay, fine. So now it has bounced to a height of h by 2. After the first bounce, the height is h by 2. Now the ball once again starts from here, bounces once again back. It loses 50% of the energy, which means it goes only to this height. Now what should this height be? H by 4, right? So therefore, from the ground, its height is seen to be h by 4. So the answer is B. Okay, now let me move on to the next one. A ball of mass 0.2 kg. This is a wonderful problem. 0.2 kg strikes a force sensor. Mass is given. Force sensor it strikes. So let us say this is my force sensor. You have a ball which goes and strikes it. Just before impact and sticks to it. Okay, after striking it, it sticks to it. Okay. Just before the impact, the ball is traveling horizontally at a speed of 4 meters per second. Speed is 4 meters per second. The graph shows the variation with time t. Okay, so you see the force initially was 0. Why is it 0? Because the ball was in air. Okay, this force is nothing but the force acting on the plate, on the sensor. The moment it hit, the ball hit the sensor, what happened? The ball just came and hit it over here and it got compressed like this. And as a result of it, then what happened? The force acting on the plate was increased and then the ball released, but it was not able to move out, right? So the maximum force at which the ball came and hit over here is seen to be F max. Okay, force slowly started increasing. And after that, once again, it started releasing. When it started releasing, then the entire force was lost. Why? Because this ball now stuck to the plate sensor. Maybe it has some glue or anything over it. It's just stuck to the sensor. And then what happened? Okay, so the ball was not able to move and it was just static over there. So, but the force that was acting on it, what happened to the force? The force started gradually to reduce and it became 0 at this point. Now, the time taken for this complete sequence of events to happen is from 400 to 440 seconds. Remember what happened over here? I'll just write two diagrams. First diagram is when it hit here. When it hit here, then this was at 400 milliseconds. Then as a result of this ball became like this, right? So why did it happen? Because all the forces are given to it. When did this happen? This happened at this point. And after that, at this point, the ball once again regained its consciousness or its sphericity. And as a result of it, okay, but it did not fall. Okay, it is still there like this. It has impinged, got compressed, and once again left it, but unfortunately it was not able to come out. Okay, now this is the process shown here. Now the question asks is what is F max? Now most of them what they do is the answers that they get is something like 20 Newton. Let me show you that this is a misconception. Now what they do is they find out what is the area on the graph. They find out like what has been asked. What is the force? What is the force over here? So towards it, they write F delta T is equal to M delta V. Just write like this. What is F maximum, which we do not know? Delta T, 440 minus 400. 40 into 10 power minus 3 is equal to M. What is M? M is nothing but 0 0.2. 0 0.2 multiplied by delta V. What is delta V? It hit and then it did not come out. It was stuck. It means final velocity minus initial velocity. What is final velocity? 4. Initial velocity 0. Sorry, yeah. No, final velocity is 0. I am sorry. Final velocity is 0. Initial velocity is 4. Okay. So now it hit over here and it did not come out. As a result of it, now they calculate this and finally they get the answer as 20 Newton, which is incorrect. Why is it incorrect? The reason is because, see, he has asked about the maximum force over here. So when does the maximum force arise? It arises in this duration, right? Which is only, this point should be 420 milliseconds. So as a result of it, your delta T here is not 40. It should be 420 minus 400, which should be 20. Thus you should have F into 20 into 10 power minus 3 should now be equal to 0 0.2 multiplied by velocity, which is 0.0 minus 4, which should now be equal to minus 0 0.8. Thus F should now be equal to minus 0 0.8 divided by 20 into 10 power minus 3. So how much will this be? 4 2s are 4 5s are 20. Now this should now be equal to 40 Newton. Okay, how do I get this? You just write this as 2 by 5 into 1000. 10 power minus 3 becomes goes to numerator, becomes 10 power 3. So in other words, this becomes 2000 divided by 5. When you do the multiplication and division, ultimately the answer is 40 Newton. Thus the answer is 40 Newton. Okay, 99% of the students had committed this mistake. I think I have not considered this in any of the misconceptions, but you can always look into it. Okay, I have given this problem to 2 batches earlier. Okay, but I've seen they commit this mistake. Okay, so see to it. Don't by heart this question because you will not get the same question again. But look into it. Okay, very, very important question. Right, now let us move on next one. Now this is again, especially your DP1 students, when you look at it, you will feel, yeah, we have not done anything on nuclear physics. How can you give a question like this? But in IB, I can give any question. Only thing is the concept should be seen. Right? So a stationary nucleus, stationary, what does it say? Stationary means initial velocity is 0 of polonium. Polonium mass, see 210 is given. It means mass 210 mass multiplied by, okay, let us write 210 is 1 mass. Let me write M1 is equal to 210. Undergoes alpha decay to form lead 206. So you have a polonium 210. It splits up into 2 nuclei. One is your alpha nuclei plus another one is your lead nuclei. So here it says 206. 206. You know what is alpha particle? Alpha particle is nothing but helium nucleus. So therefore, this should be 2He4. 2He4, which means it should have 2 protons and 2 neutrons into this. The total mass number is 4 over here. Okay. Now, the initial speed of the alpha particle, this is now moving at the speed v. What is the speed of the lead nucleus? What is the speed of the lead nucleus? Let me call this v dash only. What is the speed of it? Now, what do we do? How do we do? Now, you see, why did this split? Internal force. Whenever there is an internal force, what should you apply? You should apply conservation of momentum, right? When you say conservation of momentum, what should you do? You should say the mass of this momentum before collision. Momentum before collision is 210 multiplied by 0. This was not moving, so velocity 0 should now be equal to momentum of this one, which should be 4 multiplied by v plus 206 multiplied by v dash, right? In other words, now let us solve this. I get v dash is equal to 4 divided by 206 into v. Okay, thus this is the right answer for it. So thus, which one is the right option? D is the right option. Of course, there's a negative value, but anyway, he's asked about the speed here. So therefore, we need not consider the negative one. Negative tells you it's an opposite direction. The nucleus is going in the opposite direction. Okay, now, next, let us move on to the next one. What is the correct value for the charge on an electron? What is charge on an electron? You already know. It's there in your data booklet also. Minus 19 coulomb. But here, now where it is being given. If I use micro, 10 power minus 6 it becomes. See, you just see all the magnitudes are same. Just take like this here. 10 power minus 12 into 10 power minus 6. It become 10 power minus 18. Minus 9. So this is incorrect. 10 power minus 15 multiplied by 10 power minus 3 milli. Okay. This is also 10 power minus 18. Not correct. Let us take up this one. 10 power minus 22 into 10 to the power of kilo 3. Which will be equal to how much? 10 to the power of minus 19. Got this? So C is the right answer. Okay. So today I had taken some long time because I had some other work and somebody called me up. So I was busy. So this is the last question. Hope you would have got the answers correctly. If not, do have a look at it and learn how to solve it. Okay. Fine. Thank you. Thank you very much for watching this video until the end. And if you have watched it, if you have not skipped anything, then it's good. Well and fine. You would have learned something today. And do share these videos, such videos with your friends who are studying in some of the schools, colleges, wherever it is. It could also be of helpful to them. And subscribe to my channel for more such updates. Thank you.